Alright, today we'll be talking about analyzing data. And one of the first things we'll start with is measures of central tendency. Okay, so the big ones that you're going to use, like usual, is mean, median, mode, and where is it? Range of a set of data. Okay, so those are the big things that we'll be using with this. Okay, so mean, median, and mode we'll just define it real fast. Alright, so mean is the sum of a set of data divided by the number of data. So if you have 5 data points, you add up all 5 data points and you divide by 5. Alright, now median is the middle value or the mean of the middle two values when a data is arranged in numerical order. So you have to start at the least, go up to the greatest, and then count down to the middle two numbers or the middle number, and then find the middle number right there. If there's two middle numbers, you add them up and you divide them by 2. Okay, the mode is the value or number that appears the most. It is possible to have more than one mode. It is possible to have no mode. If there is no mode, write no mode. Do not write 0. Okay, and the range of a data set is going to be the highest value minus the lowest value. Okay, so that one's pretty simple right there. All right. Now outliers, when we're looking at this stuff, outliers are going to be data that is so far out of there that it looks like it's just messing with everything else. It looks like it's not even part of the group. So outliers are numbers that are just way far out of the number size. So like if, for example, most of our numbers are appearing between 10 and 30, and then all of a sudden we get 122, that's a huge outlier, and we don't want to include that because that's going to greatly affect our mean, our range, and well, not our mode, because if it's the only one out there, it's probably not going to affect it. It won't affect our median as much. It will affect it a little bit, but not as much as you actually think, because you're just adding one extra number. If you take it away, it might change it a smidge, to quote a person from We're the Millers. Okay, just a smidge, Okay, now interquartile range, box and plot, whisker plot, we'll talk about on the next slide, especially the percentiles and the quartiles. But bimodals, now bimodals are one of the most misunderstood ones. So I'm going to go ahead and define that for you now. Okay, a bimodal is a set of data that has two modes of info, like number of people, and amount of job offers, or amount of trees and yards. So the amount of trees would be one part of the bimodal, the number of yards would be the other part. Okay, so those ones are just going to be pretty simple. This is usually used in a frequency plot. So if you're looking at a frequency plot, you're probably using bimodal information, and bimodal is the only way to go sometimes on that. Okay? Alright, so let's head over to a box and whisker plot and really investigate a little bit deeper. Okay, so when working with box and whisker plots, you have to have data. So voila, I have data, and we're going to take a look at how it all works out. Okay, so in order to have the data set up correctly, you have to list it in the correct order. So we're going to do numerically list this out so it's a lot easier to work with. Okay, so here's all our data set up. Okay, so first things first is you draw a number line to represent all your data so you can work with it. Okay, and I would like to break it down probably in half. Probably have 20 out here, 0 right here. Okay, so 0, 20. Probably put this at 10, and it just helps when marking it out, just to mark it out and just in halves first. Don't ever do like decimals on your number line for when you're doing a box and whisker plot, because it just screws it up. Okay. Okay, so when working with this, first off, you're going to want to mark off the lowest number. So the lowest number is going to be 1, highest number is 15. So I'm going to have these be the tips of my whiskers at 1 and 15. Okay. Now what I'm going to do next is I'm going to find the mean number. So let me see, if I cut this in half, that would be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well either way it's going to be the average between these two, which is just going to be 10. So the actual median is going to be this number. So you draw a line to represent that. Okay. Okay, since I found my middle to be in between these two, so let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I actually did the wrong set of tens. I knew it would be 10, I just made a mistake as to which set of tens it was. Okay, so now that I have that down, that's going to be my median. So median, okay, so that's pretty simple. Okay, but then I'm going to do another cut down, okay, and since my median falls in between two numbers, so I'm doing the average of two numbers, I'm going to find the median between these. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the median is going to be between 3 and 5, so I add these together and I divide by 2, and I should get 4. Okay, and so 4 is going to be another, it's going to be a median of a median. Okay, and we're going to call this the first quartile, and so we call it Q1. Okay, all right, so that's Q1, and then over here 1, 2, 3, 4, 5. It's going to be between 12 and 12, which is obviously 12, so that's pretty simple. So 12 is right here, so this is going to be the other median. I'm sorry, the other median of the median, which is going to be called the third quartile. Okay. Now, what does that mean that this median is called? This median is actually the second quartile. Okay. And this one over here is called the fourth quartile. And if you'd like, you can call this the 0th quartile. Okay. All right, now that I've got everything pretty much drawn out, I can actually just start and going ahead and finishing my box. So my box, I just complete the two quartiles. My whiskers, I just attach to the box like so. And voila, I have everything all set up. Now, if you'd like to know your percentiles to match up with your quartiles, okay, 0% would be down here. This would be your 25% quartile. This one right here is your 50%, which makes sense because if the median is there, it's halfway up, half of the information above and half of the information is below. Then 75th percentile, and then this would be the 100th percentile. So for those of you guys working with your standardized tests, you can tell where you're at above people. And so now, just to be able to read the box and whisker a little bit, if you notice, this one is really big right in here, whereas this one is really small. Okay, so that means that this is not as densely packed, that I have about 5 numbers that are spread out over 6 numbers. So I have 5 numbers spread out over that. This one's a little bit more densely packed because it's the between the second quartile and the third quartile. Okay, this is about 5 numbers spread out over a total of 2 numbers, and if you look up here, that is exactly true. There's 3 10s, an 11, and a 12. So when you see it really densely packed like this, or when it's shorter like this, you're going to see a lot of numbers that are going to be really close to each other. Whereas up here, if we take a look at this one, you got 5, 2 6s, a 7, and then we skip 8 and 9 completely and go straight to 10. So that's a huge issue when you start skipping some numbers. Usually you want the median to be right in the middle and the whiskers to be kind of even as well. Okay, so this is not a normally distributed, we would call this normal distribution if it was distributed out correctly, okay? All right, but that's how you set up a box and whisker plot, and that's how you read it, and you just work with it. Okay. Now, real fast, looking at some outliers, just to give you some information, you would use what is called the inner quartile range to actually find outliers, and this is really cool how this works. Okay, so we're going to use something to find the outliers, and it's going to be called the inner quartile range. Now, the inner quartile range is just the range of numbers between the first quartile and the third quartile. So basically, in our problem, it's going to be 12 minus 4, which is going to be equal to 8. Okay? All right. So now, to find low outliers, what you do is this, is you take the first quartile, which is 4, okay, then you minus 1.5 times 8. Okay, and that should be 4 minus 1.5 times 8. Okay, so that's the lower range. So if we get numbers lower than negative 0.8 or negative 8, then we're dealing with a low outlier, okay, which is not the case. We don't even go below 1, so there's no low outliers. Okay, now high outliers are going to be 12 plus 1.5 times 8. Okay, and this is just a good way to just double check it. So we change our formula, insert 12, delete, plus. Okay, and that should be 24. So if there's any numbers above 24 or below negative 8, we have outliers. And since there is none, we have no outliers. Okay, and that's the beautiful thing about working with statistics, is you can actually use some really cool mathematical formulas to prove stuff. So if you're ever wondering, like, that kind of looks like an outlier, but it isn't actually, you can actually use this formula to help you find it. Okay, all right, that's it for analyzing data. I'll talk to you later. Bye.